So again, let's label our equations 1, 2, and 3. So if we look overall, the y's look like they could be the easiest. The x's also, whichever you feel like doing. So I'm going to get rid of the y's. So I'm going to use 1 and 2. And so 1 I'm going to keep as x plus y plus 2z equals 3. And then for equation 2, I have 2x plus y plus 3z equals 7. So right now the y's are opposite. They're the same, so I can't add them. So I'd have to subtract them. So you can either subtract everything, or if you're more comfortable like multiplying everything by a -1 and then adding it, you can do that as well. So I'm going to subtract everything. So that negative is going to get distributed to everything. So it's x minus 2x, which becomes a -x. Y minus y is going to cancel out. 2z minus 3z is going to be -z. And then 3 minus 7 is going to be -4. So that's the equation I'm going to circle, and I'm going to come back to it. So now I have to use the third equation, and I can use it with either the first or the second. So I'm going to use the first equation. So I'm going to use equation 1, x plus y plus 2z equals 3. And I'm going to use the third equation, -x minus 2y plus z equals 10. So I want to cancel out the y's again, but they're not the same. So I have to multiply the top equation by 2. So I'm going to multiply this whole thing by 2. So this is going to come out to be 2x plus 2y plus 4z equals 6. So every part of this gets multiplied by 2. And then the bottom is just going to stay the same. So we're going to leave that as -x minus 2y plus z equals 10. And then we're going to add these because my y's are opposite sides. So 2x minus x becomes x. 2y minus 2y is gone. 4z and z gives me 5z. 6 and 10 gives me 16. And I'm going to circle this. So now that is the other one I'm going to come back to. So I'm going to now stack the 2 that I had. So I have -x minus z equals -4. And I'm stacking that with x plus 5z equals 16. So here, the x's are already the same. They both have the same coefficient, and they're opposite signs. So right from here, I can add these together. So I'm going to add. These are going to cancel out the x's. And now I have a -z plus 5z, so that's 4z. And then -4 plus 16 is going to give me 12. And if I divide by 4, I get z equals 3. So I know that z is 3. So now I'm going to go back to either of my 2 circled equations and plug z in. So I'm going to use the first one, the black one that I circled. So I have -x minus z, and z is 3, equals -4. So -x minus 3 equals -4. So -x equals, if I add 3, -4 plus 3 is going to give me -1. And then I divide out the negative, and I end up with x equals 1. So now I have x, and I have z. So now I'm going to go back to any of my original 3 equations and plug in x and z and solve for y. So I'm going to use the first one. It doesn't matter which one you use, so I'm just going to go use the first one. So x is not 1, y we don't know, so plus y, plus 2z, and my z is 3, equals 3. So 1 plus y plus 6 equals 3. So 7 plus y equals 3. And then I subtract my 7. So y equals -4. So now I have x, I have y, and I have z. So my answer, I'm going to put it in an ordered triple. So x first, then the y, and then the z. So here is my final answer. Okay, so same idea here. I'm going to label them 1, 2, and 3. Now the third one doesn't have a C term in it. It only has an A and a B. So we can do a couple of different things here. We could solve for A, and we could substitute A into both equation 1 and 2 to get rid of A's altogether and have B and C. Or we can use equations 1 and 2 and get rid of the c, and then use that answer with number 3. So either one is fine. So let's keep practicing with elimination. So let's use 1 and 2. So 4a plus 2b plus c equals 2. And then equation 2, we have 5a minus 3b plus 2c equals 17. So I want my c's to cancel out. So I'm going to multiply the first equation by a negative 2 in order to make that a negative 2c. So I'm going to distribute that negative 2 to everything. So I have a negative 8a minus 4b minus 2c equals negative 4. The second equation, I'm going to just keep that exactly the same. So 5a minus 3b plus 2c equals 17. So now, because my c's are opposite signs, I can add. So negative 8a and 5a is going to give me negative 3a. Negative 4b and negative 3b gives me negative 7b. My two c's are going to cancel out. And then negative 4 plus 17 is going to give me 13. So this equation that I'm going to circle, I can now use that with equation 3, since they only have a's and b's in them. So I'm going to do that. I'm going to do negative 3a minus 7b equals 13. And I'm going to stack that with the third equation. So that was a minus 5b equals 3. So what I can do is I can multiply the third equation here by a 3 to make my a's cancel out. So let's just rewrite this. That's going to be negative 3a minus 7b equals 13. And then this is going to become 3a minus 15b equals 9. So since my a's are the same number but opposite signs, I can add. So negative 3a and positive 3a is going to cancel. Now I have a negative 7b and a plus a negative 15b. So that gives me a negative 22b. And then I have 13 plus 9. So that gives me 22. If I divide by negative 22, I get that b equals negative 1. So I already have now what b equals, so now I could use either the circled equation or equation 3 and solve for a. So I'm just going to use equation 3, because we didn't use it that much. So I'm going to go up here and I'm going to say a minus 5 times b, which is negative 1, equals 3. So a is going to end up being plus 5. So the negative 5 times a negative 1 equals 3. And now I subtract 5 and I get negative 2. So a is negative 2 and we know b. So now I can go to one of the first two equations and plug in my a and my b. So I'm going to go to the first equation. So I'm going to kind of section that off real fast. So 4a, I know a is negative 2, plus 2b, which I know is negative 1, plus c equals 2. So this gives me negative 8 minus 2 plus c equals 2. So negative 10 plus c equals 2. I'm going to add my 10. So c equals 12. So now I know a, b, and c, and I'm going to write it as an ordered triple. So a is negative 2, b is negative 1, c is 12. So here is my final answer. So here we have a word problem. So first we need to create our three equations, and then we need to solve them. So you manage a clothing store and budget $6,000 to restock 200 shirts. So since we have money and we have a number of shirts, that's going to be two separate equations. We're going to have an equation for money. We're going to have an equation for the amount of shirts. So it says you can buy t-shirts for $12 each, polo shirts for $24 each, and rugby shirts for $36 each. So we want to have twice as many rugby shirts as polo shirts. So how many of each type of shirt should you buy? So we know that there's t-shirts, polos, and rugbies. So let's call them T, P, and R. So t-shirts plus polo shirts. So these are the amount of. So the amount of t-shirts plus the amount of polo shirts plus the amount of rugby shirts has to equal 200 total shirts. So these are all the amounts of shirts. Now we need a second equation that has to do with the money. So t-shirts are $12. So $12 times however many t-shirts there are, plus $24 times however many polo shirts there are, plus $36 times however many rugby shirts there are has to equal the $6,000. So that's our second equation. Now the third equation, it says we want to have twice as many rugby shirts as polo shirts. So if we want twice as many rugby shirts, that means we need more rugby shirts. So double the polo shirts will be our rugby shirts. So our third equation, we're going to say is 2P equals R. The number of rugby shirts is 2 times the number of polo shirts. So now that we have 3 equations, we can solve this whichever way makes sense to you. So because we have that third equation and we know that R equals 2P, it makes sense to plug in 2P instead of R in both of the equations. So if I use my first equation, T plus P plus R, instead of R, I'm going to put in 2P. So now this equation is T plus 3P, because I have a P and a 2P, equals 200. So now I have 2 variables instead of 3. So I'm going to put a 1 here. And I'm going to do the same thing with the second one. I'm going to take 12T plus 24P plus 36, and instead of R, I'm going to put in 2P. So now I have 12T plus, so I had 24P, but I have 36 times 2P, so I have another 72P. So 24 and 72P is going to give me 96P equals 6,000. And this is equation 2. So now I could take my 2 equations and I can do regular elimination now because I have 2 variables. So I'm going to do T plus 3P equals 200 and 12T plus 96P equals 6,000. So now we want to eliminate something. So it would be easiest here to just multiply the top equation by a negative 12. So this becomes negative 12T minus 36P equals negative 2,400. The bottom equation is going to stay exactly the same. So 12T plus 96P equals 6,000. And now I can add these together because my T's are opposite sides. So these are going to cancel out. I have negative 36P plus 96P, so that's going to give me 60P. And then negative 2,400 plus 6,000 is going to give me 3,600. So now if I divide by 60, I get that P equals 60. So there's 60 polo shirts. So since I know there's 60 polo shirts, I can plug that back in now and say 2 times 60 equals R. So R equals 120. And now that I know R and P, I can go to my original equation and find T. So T plus P, which is 60, plus R, which is 120, equals 200. So when I go to solve this, I have T plus 180 equals 200. So T equals 20. So in this case, instead of writing my answer as an ordered triple because it's a word problem, I'm just going to write it out. And I'm going to say T-shirts equals 20. So there's 20 T-shirts. I'm going to say that polos equals 60. And rugby equals 120. And then this would be my answer.